Mr. Jones looks at the prices of 5 mansions. He wants to look at mansions costing between £990,000 and £1,110,000. Write the letters of the mansions that he looks at. So first we have 989,990. That's less than £990,000. Because if we look, we have a 9 as our 100,000s digit, but we only have an 8 as our 10,000s digit, and we have a 9 in the number that we're comparing it to. So this number is less than 990,000, which means that Mr. Jones does not look at it. But now we have £1,050,000. So Mr. Jones does look at Mansion B. We can tell that that's more than 990,000 because this number only has 6 digits, but this number has 7. But it's still less than £1,110,000 because here we have a 1 in the millions and a 1 in the 100,000s. But here we have a 1 in the millions but a 0 in the 100,000s. So this number is less than this number. Now 1,200,900. So Mr. Jones will not look at this because that's more than 1,110,000. We can see that here we have a 2 as our 100,000s digit, so that's more than this number, which only has a 1 in the 100,000s. Now 1,105,000. Mr. Jones will look at this mansion because it's more than 990,000, but less than 1,110,000, because here we have ones in the millions, 100,000s and 10,000s, but here we have a 0 in the 10,000s, so this number is smaller. And finally, we have £991,500. Mr. Jones will look at that because it's larger than £990,000. We have a 1 as our thousands digit here, but a 0 in the number that we're comparing it with, so this number is larger than this number. So Mr. Jones will look at B, D and E. This design has 1 large square and 2 identical small squares. The design measures 36 centimetres by 28 centimetres. Calculate the length of a side of the large square. So if we look at this length of 28, that's the total of the length of 1 large square and 1 small square. So we can write 1 large plus 1 small equals 28. And if we look at this length of 36, that's 1 large square, but this time we have the length of 2 small squares. So we can write 1 large plus 2 small equals 36. So we can see that what's different about these is that our second statement, so this statement down here, this length here, has 1 extra small square. So we can take the length of 1 large square and 1 small square, and if we rotate it and move it down, we can see that it's the same size as 1 large square and 1 small square here, because remember, squares will have sides that are all the same length. So we have 28 plus an extra small square is 36. Now 28 plus 8 is 36, so the length of 1 small square must be 8 centimetres. This second statement we've written is 8 larger, and all that's different about it is that it has 1 extra small square. So if we know that this length is 8, the other length of the small square will be 8 as well, because the small squares are identical. So we have 8 plus a large square is 36. Now 8 plus 8 is 16, and then 16 plus 20 is 36. So that means the length of 1 large square is 20 centimetres. And we can see that if we have 8 here and 20 here, that adds up to 28. So we can be confident that we've got this correct. The length of a side of the large square is 20 centimetres. Here is part of a number line. Write the number shown by the arrow. So on this number line, we can see that we have 5,900,000 and 6 million labelled. So what we can do is find the difference between our labelled values. So work out 6 million minus 5,900,000. That's 100,000, because the difference, if we add 100,000 to 5,900,000, that will take us to 6 million. Now to get from this number to this number, we have 1, 2, 3, 4 jumps. We know that the total difference is 100,000, and because we have 4 jumps, we can divide that by 4 to find the value of each jump. So to find what each of these little lines on our number line represents. 100,000 divided by 4 is 25,000. So this line here is 25,000 more than 5,900,000. So that must be 5,925,000. Here is an isosceles triangle. Calculate the size of angle X. So when we're calculating angles in a triangle, we need to remember that angles in a triangle add up to 180 degrees. Now we're told that this is an isosceles triangle, and isosceles triangles have 2 equal angles. So as well as this length being the same as this length, this angle here will be the same size as this angle here. And even if we didn't remember that isosceles triangles have 2 equal angles, we could spot that they've used the same letter for both angles. They haven't written angle X and angle Y, they've used the letter X for both of them, which tells us that they will both be the same. So we know that the total has to be 180. So 110 plus X will be 180. So if we subtract 110 from 180, that tells us that the angle X's together will be 70. So these 2 angles here will have a total of 70, because 70 plus 110 gives us 180. And if we know that 2 angles are 70 and they're the same, to find one angle we can divide 70 by 2, and that gives us 35. So angle X is 35 degrees. Here is a sequence of shapes made from squares. There is a formula which connects the number of squares, s, used in a shape with the shape number, n. Tick the correct formula. So first we have s equals 3n plus 2. And it's important to understand that 3n means 3 times n. So let's look at our table and see if this formula works. We have 3n plus 2. So if the shape number is 1, that's 3 times 1 plus 2. 3 times 1 is 3, plus 2 is 5, and that's the number of squares. So this formula is looking promising. Let's try it for shape number 2. So that will be 3 times 2 plus 2. 3 times 2 is 6, plus 2 is 8. But we only have 7 squares in this shape, so it won't be this formula here. So let's try the next one. That's 3n plus 1. So 3 times n plus 1. If n is 1, 3 times 1 is 3, plus 1 is 4, not 5, so we know that it won't be this formula either. So let's try s equals 2n plus 3. If n is 1, that's 2 times 1 plus 3, so that's 5. If shape number 2, that's 2 times 2 plus 3, 2 times 2 is 4, plus 3 is 7. If n is 3, 2 times 3 is 6, plus 3 is 9. And if n is 4, 2 times 4 is 8, plus 3 is 11. So this formula here is the correct formula. That's s equals 2n plus 3. Because if we multiply the shape number by 2 and then add 3, we get the number of squares in the shape. What is the volume of this standard size box of salt? So the volume is the amount of space that a 3D shape takes up. And we can see that we have a cuboid. And to calculate the volume of a cuboid, we multiply the length times the breadth times the height. And they've given us the dimensions. So we just need to work out 10 times 6 times 5. 10 times 6 is 60, times 5 is 300. So the volume is 300 centimetres cubed. Now, what is the volume of this special offer box of salt, which is 20% bigger? So the volume will be 20% more than 300. So we need to find what is 20% of 300. That's 60, and we could either get that by dividing 300 by 100, so that's 3, and then multiplying by 20 to get 60, or we could divide by 10 and times by 2. 300 divided by 10 is 30, so that's 10%, times 2 to get 20% gives us 60. Or the other way of calculating 20% is dividing by 5, because 20%, 20 hundredths, is the same as 1/5. So it's 60 centimetres cubed larger, and 300 plus 60 is 360. So this box of salt, which is 20% larger, is 360 centimetres cubed. Now, the standard size box contains enough salt to fill up 10 salt pots. How many salt pots may be filled up from the special offer box of salt? Well, it will be 20% more than 10. So 20% of 10 is 2, because 1/5 of 10, or 10 divided by 5, is 2. So this special offer box will be able to fill up 2 extra salt pots. So if this box can fill up 10, and this box can fill up 2 more, that's 12 salt pots altogether. Here is part of a number line. Write the numbers shown by the arrows. So we have 0.4 and 0.6 labelled, and our first arrow is right in the middle of those, so this will be 0.5. But now we need to find the value represented by this arrow here. Now when we have decimals on number lines, it's often easier to write zeros on the end, and we can do that because 0.40 is the same as 0.4. All this 0 tells us is that we don't have any extra hundredths. So we can have 0.40, 0.50 and 0.60. And that makes it easier for us to understand what the values in between will be. So here we will have 0.45. If we ignore the decimal points, that makes sense because 45 is in the middle of 40 and 50. So 0.45 is in the middle of 0.4 and 0.5. So here we will have 0.55, and then here where the arrow is pointing will be 0.65. Calculate the area of the triangle. So the area of the triangle is the amount of space that it takes up, and we find the area of a triangle by multiplying the base times the height and then dividing by 2. So we can see that the base of our triangle is 8 centimetres, and then the height is from the base to the highest point, so that's this line here. Now we need to decide whether this is 5 centimetres or 6 centimetres. We can see that it's 5 centimetres. 6 centimetres just tells us the length of one of the sides, but we want the height, and the height of a triangle isn't always the same as one of the side lengths. So we need to multiply 8 by 5 and then divide by 2. 8 times 5 is 40, divided by 2 is 20. So the area of the triangle is 20 centimetres squared. The rule to get each number in a sequence is subtract the previous number from 100, then divide the answer by 2. Here is part of the sequence. Write the two missing numbers. Well, first, let's look at the numbers they've given us and check that we understand how the rule works. So here we have 40. If we subtract 40 from 100, that's 60, and then 60 divided by 2 is 30. So that's the next number in the sequence. So to find this number here, we need to first subtract 33.75 from 100. Remember, if we're subtracting a decimal from a whole number, we can write a decimal point and then zeros on the end of the whole number. So we've got our decimal points lined up, so we copy down the decimal point, and now we can use column subtraction, and when we do that, and we need a lot of exchanging here, but that gives us 66.25. So we've subtracted the previous number from 100, and now we need to divide the answer by 2. So to work out 66.25 divided by 2. So we can copy up the decimal point, use short division, and that gives us, if we extend with a 0, 33.125 as the next number in the sequence. Notice when we were dividing, we got to the end and still had a remainder, so we wrote a 0 on the end of our dividend, and we can do that because 66.250 is the same as 66.25, but it means that we can write the remainder in front of the next digit. But now, let's work out this number here. So we know that this number has been subtracted from 100 and divided by 2 to get 40. So before it was divided by 2, we can multiply 40 by 2, and that's 80. So 80 divided by 2 is 40. And then, because it was subtracted from 100, 100 minus 80 is 20. So this number here is 20. We subtract 20 from 100 to get 80, then divide the answer by 2 to get 40. And that's the next number in our sequence, so we can be confident that we've got this correct. In Class 6, 80% of the children like crisps. 75% of the children who like crisps also like chocolate. In Class 6, what percentage of the children like both crisps and chocolate? So we know that 80% like crisps, which means that 20% don't like crisps, because percentages need to add up to 100% in total. And we know that 75% of the 80% also like chocolate. Now what helps us is if we know that 75% is the same as 3/4. That's because 3/4 is equivalent to 75 hundredths. So 3/4 of these 80% of children who like crisps also like chocolate. So to find 3/4 of 80, we can divide by 4. So 80 divided by 4 is 20. And then we can multiply by 3, and 20 times 3 is 60. So 60% like both crisps and chocolate. We can say that 3/4 of 80% or 75% of 80% is 60%.